Okay, so I'm just going to put a triple slit in here. I'm trying to work out the law of reflection, and I put a concave lens in there and I put the mirror in there. So I'm just marking all the lines out there. So those ones are the reflected rays, and then I draw a line for the mirror, and those ones are the incident rays. Are all diverging, so I get different angles. And so when I get, that's what it looks like, all the dots there. So I just made a mistake with that line there, but just rubbed that out. So drawing in the first incident and reflected ray, and then the second and third, and then where they hit the mirror, I'll just draw a line at 90 degrees. That's my normal, so I can calculate the incident and reflected rays. And so just putting arrows on all of them, labeling them as reflected, labeling them A, B, C. And then finally I can just measure them out. So I get at the protractor. It's out by, I think the worst one's out by 3 degrees. Most of them are just out by 1 or 2 degrees because just with the measuring, error in measuring. So we've got 32 and 30. So they're equal, more or less. 35, 37. So they're sort of equal. And it gets larger, 44, 45. And so all the angles are equal. So that is the law of reflection. That's the answer. Is the angle of incidence greater or less than or equal to the angle of reflection? It's the same. And that's what the angle law of reflection is. Angle of incidence equals angle of reflection. Just having a look there, the diverging rays did remain diverging, so the mirror doesn't do anything. As with the parallel, these remain parallel, and the converging is a little bit more confusing because they converge and then they sort of go past each other. It looks like they're diverging and spreading out. So I do a range of lengths of reflecting. You can see that doesn't change either. So the straight mirror does keeps the nature of the wave pretty much the same.